Okay, so the second question I want to go over is this one. Again, we started this. In fact, if you stick around, I did most of it. So let's kind of do this. We'll start from the beginning. You got to take the root of this, which this is from the previous one. You have the power rule. So we're going to do 2 times u n minus 1 times du, which is 1. And we're going to do the power rule again, which is 2 times u. This time it's y minus 4. N minus 1 is to the first, times the derivative of this, which is 1 y prime. Remember, anytime you take the derivative with respect to y, it's going to be y prime equals to the derivative of 1 is 0. Same strategy as before. We're going to get y prime by itself and take everything else to the other side. This is the 1. So I'm going to get 2y minus 4 times y prime equals 2. Move this over. So that's going to be minus 2x minus 3. Okay, then we divide because we want to solve for y prime by 2y minus 4. So negative 2x minus 3 over 2y minus 4. The 2's will cancel, you'll see that, and then you got to distribute the negative, so we end up with y prime equals negative x plus 3 over y minus 4. Okay, and that gives us our solution to that problem. However, they do ask us to evaluate when x equals 3.8 like the previous problem, except they don't give us a y. So we're going to use this 3.8 into the formula, and we're going to solve for y. So we don't have y equals to 1. We're going to figure this out. So 3.8 minus 3 would be 0.8 squared plus y minus 4 squared equals 1. 0.8 squared is 0.64 plus y minus 4 squared equals 1. Subtract 0.64 from both sides, you would end up getting 0.36. Square root of both sides equals plus or minus. Anytime you take the square root, you always get plus or minus, so plus or minus 0.6. Add 4. Mind you'll have two solutions, 4 plus 0.6 and 4 minus 0.6. So that's going to be 4 minus 0.6 is 3.4. Second solution would be 4 plus 0.6, which is 4.6. Okay, so those are our two solutions, which lead us to our two coordinates. This time we're going to have to evaluate 3.8 comma 3.4 is one of them, and the other one is 3.8 comma 4.6 is the other one. Okay. From here, we want to do, now we can do what we did on the previous problem, which was evaluate, right? So we're going to evaluate y prime evaluated at 3.8 comma 3.4. And all that means is plug 3.8 and 3.4 into here. And so when I left class, I think I might have had some miscalculations, but you can correct it here. So here, at this point, negative 3.8 plus 3 over 4.6, no, not 4.6, 3.4 minus 4. Okay, so again, plugging in 3.8, 3.4 into here. 3.8 for x, 3.4 in for y. That's all I did. Okay, so then from there, I end up with negative 3.8 plus 3 is negative 0.8. And 3.4 minus 4 is actually negative 0.6. And that's where I think I might have had the mishap there. Which the negatives cancel out. And then a trick would be I can multiply that by 10 to get rid of the decimal. You get 8 over 6, which reduces to 4 over 3. So you get 4/3. Okay? So from here, you end up with y prime. We're going to evaluate the other one. So 3.8, 4.6. Okay, so we're going to evaluate that one. So again, just plug in 3.8 for x and 4.6 for y. So we're going to end up with negative 3.8 plus 3 over 4.6 minus 4. That gives us negative 0.8 on top over 0.6 on the bottom. And we just end up with negative 4/3. Okay, same trick, you change it to 8 over 6, reduce it, it's 4 over 3. Okay, so that's what we found. And real quickly, because it just asks us, then find the equation of the tangent line. Okay, so here, using this point, both points, the tangent lines, so we got to take it one step further. These are the slopes at those points. So we're going to use that point and that slope in the y and the point slope formula. Okay, so I'm going to turn the here. So we'd end up with y minus y1 equals to m times x minus x1. So the y minus y1 part, that's 4.6, equals to the slope would be 4/3 right here, minus x minus, oh, not 4.6, let's use this one, 3.4 first. We'll do 3.4 first, and then 3.8, and our slope was 4/3. Multiply that, and for that I'd use a calculator. Okay, so we'd end up with 4/3 x minus 3.8 times 4/3. Okay, 3.8 times 4/3. I get 5.06. So this is minus 5.06, but I can round to 7. And add 3.4 to both sides. And then I get y equals 4/3 x plus 8.467. Okay, it is my equation there. I could do the same thing, okay, with y minus 1 for the second one, right? So it's going to be y minus 4.6 equals negative 4/3 times x minus 3.8. Distribute and then negative 4/3 times negative 3/8 or 3.8, 5.06 again, positive, round to 7, and then add by 4.6, 9.67. Okay, and here, just so we get an idea, okay, I'd like to go here to, so just so you see the screen, what did we do? Okay, that's always the question. You can go to Desmos.com. This is a graphing. I'm going to search Desmos graphing. Okay, so here I'm going to type in the original equation, which was x minus 3 squared. The nice thing about this, it graphs pretty much anything that you'd want to graph, plus y minus 4 squared, right? That was the original equation, equals 1. So that's just like I said, that's what it looks like. But now what did we do? Right, we found these two equations, so I'm going to write them up. Y equals 4/3 x minus 5.07, minus 5.07. Okay, let me check something here. No, we didn't get 5.07. We got 8.467. 8. 8.467. No, that's not there either. Okay, here, correction on this one. This should have been minus, and then plus 3.4 would give us a difference. It would give us negative 1.67. Negative 1.67. Yeah, and I knew it was off because this line's supposed to touch. Okay, so finally, minus 1.67, that touches. Okay, so what do we find? Where does it touch? Well, at our point where we wanted it to. It's 3.4, 3.8, 3.4, 3.8. You see it here. This is 3.4. That's about 3.8. Okay. So that's where we found it to touch. Or I'm sorry, 3.8, 3.4. That make more sense. Okay, so there it is, and we could even hover a point around that, which that's probably as close as I'm going to get right there. 3.8, 3.4. Okay, what about the other one? So now let's graph the other one. So if we did that right, y equals negative 4/3 x plus 9.67. Okay, and that touches the line, so that's a good sign. And you'll see the other solution there for our tangent line, 3.8, 4.6. Okay, so that's what we found. All right, so next one. Okay, so this one a little bit more straightforward. The last one, yeah, I'll admit that's a ton of steps. But here we'll do just the differentiation. Okay, so however, there is a product rule within a natural log, so we'll have to do this using what we did in the previous section, and also the product rule, the natural log of u. So two rules to recall: the d dx of ln u equals du over u, and then the other rule is d dx of the first times the second unchanged. So this is one of those 2-in-1 functions that y'all like so much. So we'll just go ahead and do it. So the derivative of this would be du, or u would go on the bottom. So the 9 is just going to kind of hang out, right? U is going to go on the bottom. What's u? It's x times y. What's du? Well, that's the derivative of the first, which is 1, times the second unchanged, which is y, plus the derivative of the second, which is y prime, times the first unchanged, which is x. Okay, so that's a y prime. Equals 2y times y prime, derivative of negative 1 is 0. Okay, so we have the same strategy we've had before. We probably want to get rid of the xy, make it a little bit easier, and distribute the 9. So multiply both sides by xy. Okay, I'm going to do 2-in-1 here. So this is going to be 2 times xy squared y prime. So that's multiplying this by xy. Over here, if I multiply it by xy, it'll just go away, right? Because the xy's will cancel out. And now I'm going to distribute the 9, so that's 9y plus 9x y prime. 9 times y prime x is 9x y prime. So I want to get all the y primes by itself, so scoot that over. You end up with 9y equals 2x y squared y prime minus 9x y prime. Factor out the y prime. So you get y prime, and write what's left over, 2x squared y squared, 2x y squared, 2x y squared minus 9x, okay, and then just divide, right? So in fact, I'm gonna write the y prime on this side, and then so that means it would be 9y over that, over 2x y squared minus 9x. Okay. And then it says evaluate. Okay, well that's kind of the easy part. Y prime evaluated at 1, 1 equals to, just plug in ones for y and x. 9 times 1. On other problems you got to be more careful, but here, since they're both ones, we'll just plug away. That gives us 9 over 2 minus 9, which is negative 7. Negative 9 cents. Okay, so that's that answer there. Okay, so final one. It says the demand is the number of items that can be sold at a price of p dollars for x equals to the root 5,000 minus p squared. Find the rate of change of p with respect to x by differentiating explicitly. Okay, so in other words, differentiating from here. So I probably want a rewrite step for this. Okay, so there's no avoiding that. So it'd be 500 minus p squared to the 1/2 power. So from here, we'll take the derivative. So derivative of x is 1. Derivative of this is like u to the n, so it's 1/2 5,000 minus p squared to the negative 1/2 times du. What's the derivative of this? Would be, that's 0, that would be 2p. 2p or negative 2p times p prime, okay? Because it's with respect to x. So the p, don't let it throw you off, that's now acting like the y. Okay, so if I want to solve for p prime, I would divide both sides by this, which is 1 over 1/2 times, I might just go ahead, we'll save it. 5,000 minus p squared to the negative 1/2. Okay, now I'll rewrite this right here. Oh, equals to, oh, also I got to divide, so I divided this part, but I also got to divide that. Well, here I could have said that cancels out, right? So that's, the 1/2 of 2 is just 1. The negative doesn't cancel out, so I got to keep the negative. And then also keep the p. Okay, so negative p, yeah. So again, 1/2 of 2, that's 1, and then negative p right here. So again, what am I trying to do? I'm trying to divide all this and leave p prime on this other side. Okay, so we've accomplished that, but now, you know, the negative exponent could also mean that this moves to the top. Okay, so if it's in the denominator, the negative exponent means it can move to the top, and then 1 over 2 just means the square root. So what I'm going to do is, it's 1 times the square root of 5,000 minus p squared over what's left is negative p. But again, emphasis on the negative exponent, I could just move that to the top. And a couple of things I can clean up. One is unnecessary. The negative I can just pull out here. Okay, that's the same thing. That's usually how you'll see it. Equals to p prime. And so we did it. Now another thing, so we found p prime, or in other words, the rate of change of p, that is p prime. They could ask us a follow-up question, for instance, what's the price if demand is 100? Okay, or no, what's the rate of change of price if the price is, you know, a certain amount, like 100, yeah. So if price is 100, what's the rate of change of price? So they could ask you that. Okay, so that's basically it for this problem. Okay, so I just wanted to kind of clarify. I know we kind of rushed at the end, so I just want to make sure you had what you needed for this week's assignment. Y'all have a good week. I will see y'all next Saturday. See you then. Take care.